Boom. Hopefully the audio works on this one. Unit 2, Roots and Powers. Here we go. This is my booklet. I am Dweedoff. You guys are block, what is this, B? That color isn't great, so let's get rid of that color. Slide these colors over. Okay. Flip the page. Here we go. So this is not the first time you guys should have seen exponents. If you have your phone out, please put it away. I see some, either you're awkwardly looking into the abyss, or you're on your phone. Not the first time you've seen exponents. You've seen exponents before, and just like when we were introducing or reintroducing some of the basic operations in our first unit. So, well, what's the point of multiplication? Well, the point of multiplication was to deal with repeated additions. What's the point of exponents? Why do we use them? Why were they developed?
Make numbers that multiply by themselves easier to write.
Yeah, to make numbers that multiply themselves easier to deal with. So we've got something like this. I got 2 cubed sitting here is how we would read that. Or 2 to the power of 3. Different ways to say this. This expression has some pieces to it. One of those things is called the base. One of those is called the exponent, which is which? Top number is the exponent. And what does it tell you, Dea? How many times what number? The big number. Okay. So what if that's the exponent, then the big number is the? Big number is the base. So the exponent is how many times the base is multiplied. And the base is the number that does get repeatedly multiplied. Exponent tells you how many times. Together, we call this thing a power. And we can write this thing in other forms. So this power expression here can be represented a few different ways. There's an equal sign somewhere that shouldn't be. What does it mean to take 2 cubed? Well, if 2 is the base, 3 is the exponent. Dea said the exponent is how many times the base is multiplied. We could write 2 cubed as 2 times 2 times 2. We have a name for this. The form here is repeated multiplication. Repeated multiplication. It's a long word to spell. So you got power form. We've got repeated multiplication form. And then, of course, what is 2 cubed? It's 8. 2 times 2 is? 2 times 2 is 4. 4 times 2 is? 8. So if this is power form, this is repeated multiplication form, this is what we call standard or evaluated form. We've got names for all these forms. So exponents, 2 cubed. 2 cubed equals this equal sign in the middle should not be here. 2 times 2 times 2. 5 squared would be 5 times 5. Get rid of that guy there. There's some equal signs that made their way in here that definitely shouldn't have. And we can go the other way too. If I wanted to condense this down into something more usable, whose ruler is that? Dave, is that your ruler behind you there? Or is that my ruler? Yeah. If I have 3 times 3 times 3 times 3, how could I write that in more condensed notation, in power form?
3 to the power of 3.
The thing that's getting multiplied is 3. How many times is it getting multiplied? 4 times. So I got a 3 to the power of 4 in there. Here I could make this guy 7 to the third. All sorts of ways to say this. We could call 7 cubed or 7 to the power of 3. Now, if you'd like to get a calculator out, you may now get a calculator out. I want to make sure that you're all comfortable with how your calculators handle this. If you do not have a calculator, come borrow one from me. I got a bunch of if you're borrowing a calculator, you got to put your phone in the slot. Phone goes in the slot. Or AirPods can go in the slot. I want to make sure all of you know how to use your calculator. I will demonstrate with a couple different ones. Oh, I need one more. Okay. So I've got a few different kinds of calculators in there. I will demonstrate how my different calculators work with these things, and you need to know how yours works with these things. So here's how you input exponents on a calculator. Every calculator works a little different. You need to know how yours works. If you don't have your own, get your own. Two-line display scientific calculator. There's a few options here. Some calculators will have an X to the Y button or this little arrow up here button that will represent the exponent key. Some of them will shortcut them for you in other ways, but I'll show you what these... So I got 3 calculators here. I got these 2, and I got this guy. I'll start with my least favorite, this guy up here. So on this particular calculator, I don't know if any of you have it in front of you or if you bought it yourself. This is a Y to the X button here. Is there a square? There's also a squared button on this calculator. There's also a cube button on this calculator. So if you need to square something, you can push the square button. If you need to cube something, you can push the cube button. But this one will do everything. So to use it, if I wanted to do my 7 cubed or whatever, I'd push, first you push the base, the number that you want to exponentiate. And then we're going to push our Y to the X button on this calculator. And it creates that symbol. I don't know why it doesn't just use that symbol then for the key. I don't know. So, but now we're going to go here and say, okay, well, I want 7 to the power of 3. There it is. 343. This pink calculator here on the left, the button is different. It is an X to the box button. It's that guy right there. This is my absolute favorite calculator of all the ones I own. That button is the power button on this calculator. So if I got 7 to the power of 3, I would push 7. I would turn it on first. And then I would push 7. And then I would put this X to the power of box button. And it creates a little box up there. That little box, if I just start punching in numbers, it will continue to grow. So I push like a 3 and then a 5 and then a 6 plus 2. Like I can just keep going. All of this is showing up in the exponent. I don't want that. I just want 3. So then if I want to get out of the exponent, I have to hit this little arrow over here and then it drops me back down. So 7 to the power of 3, I push the little box button down here. And it sure as heck better be the same number as the other calculator, 343. That's that calculator. That's the Casio. The TI works similarly to both of these. Clear U. If I got push 7 because I want 7 to the power of something. This is the exponent button on this calculator. Gives you the same notation that the Sharp calculator did. 3 equals blah. Nice and easy. Questions about how your calculator works? Yes. You have a crappy calculator. Yeah. Bosco, can you pass me Williams' calculator? Okay, so it's a Sharp, so it works the same way as the first one did. 7, Y to the X. But you can't actually see what's happening here. You just have to assume that your calculator is listening to you. And then 3, and then enter. It's exactly the same as the first one, except it doesn't show you what you're doing. Which is why I told you to get 2. Who's Ethan Bay? Sorry. Anthony Bay. Tell Anthony get better calculator. Well, he probably got a better calculator, and then you got the crappy cast-off calculator. Is that what happened? Why do you have his if you didn't buy a new one? Oh. Anthony should have got a better calculator. Okay, with your hello, good morning. What's up? Of what? Any of you opposed to being filmed in class? Students being students? If you want students being students, then all of you need to pull out Clash Royale on your phone. Okay, yeah, I don't mind if they don't mind. If any of you can, but seriously, if any of you are opposed, say so now, and I will kick the camera out of here. No? Okay, go for it. Okay, so what I want you to do is I want all of you crank this out. Just evaluate these four in your calculator. Make sure you're comfortable with how the calculator works. If you don't have a calculator, borrow one from me. It's not overly complex. What did your calculator say? Bang. Oh, okay, crank them out. Evaluate powers with the calculator. Yes, the Staples one works exactly the same way. Yours is still wide as where's your base? You assume the calculator is listening to you, nothing's changing on the screen. You're gonna want to get a 2 on display calculator. Okay, 2 minus calculator. Don't look too far. No. No. Ready? Do this. Already made a mistake. Don't let your notes unless I do it with you. Nope. Do not feel. Don't work ahead, guys. On this one, do not work ahead. I've seen 3 people work ahead, and all 3 of you did it wrong. Don't do it. Not today. Not today. Here we go. So you guys seem like you're good with the calculator because some of you are trying to work ahead. Don't work ahead. 5 to the 4. What is it? What's the value?
625.
625. Very good. 4 to the 3.
64.
64. No worries. 13 to the power of 1. 13. And 10 to the power of 5.
100,000.
100,000. 100,000. All y'all should be able to get your calculators to do this. Okay, cool. Keep the calculators handy. We're going to talk about something here. Okay, so here we go. Bed mass is important here. Okay, so here we go. What does it mean? It bases with negatives, and this is where things get a little bit dicey. What does it mean to put a negative number in front of something? Mathematically speaking. If I have -2, just kind of chilling like that, what does that mean mathematically?
You're -$2.
No, that's not what it means mathematically. What does it mean to have -$2? That also doesn't make sense. That you owe $2. I want a mathematical, not a financial. What is -2? Wow, what's another way we could write -2? Yeah. I could write it as 0 minus 2. Okay, what's another way I could write it? Mathematically. If I told you the answer was -2, one of the questions could be, okay, what's 0 minus 2? Cool. What's another way I could write that? More simply. Not using addition and subtraction. Fair enough. Go the other way. No. No, other way. Put the negative on the other thing. -1 times 2. This is the way. What? Who's trying to connect to my TV? Mr. Keeley?
No, can we see what they're doing?
Just for fun. But I don't know how to get it back. Doing? Oh, yeah, I didn't laugh. I was not expecting. Okay, so the way I want you to think about negatives is to think about them as multiplication statements, and then what happens here is going to make more sense. Negative 2, yeah, you can write it as 0 minus 2. You could also write it as negative 1 times 2. So if I have negative 2 to the 3 here, the way this is written...
2 to the power of 3, and then the minus is not affected by the power.
Yes. But nobody heard what Bosco said in the back corner of that classroom. The way this is written implies that what you have here is 2 repeatedly multiplied because the exponent gets dealt with before this multiplication by a negative does. And then the negative 1 gets tossed out front. So what's getting repeatedly multiplied here? A 2. The negative only shows up once. The exponent is the 3. And negative 1 times 2 times 2 times 2 is negative 8. Okay? With things like this, we need to make sure that we take bed mass into account. The exponent needs to get applied before that negative gets multiplied on. We repeatedly multiply first and then tack on the minus sign after. What if, though, I have brackets? I put a bracket around my negative 2, and the exponent then goes on the outside. This is the same as having negative 1 times 2 inside a set of brackets, and then putting it to the power of 3. BEDMAS says I do what first? Do the brackets first. So, is there math to do inside the brackets here? Yeah. Negative 1 times 2 is negative 2, and that's the thing that gets repeatedly multiplied when there's brackets present. So what's the base in this case?
Negative.
It's going to be negative 2. The exponent is still 3. The expanded form looks like this instead, though. Negative 2 times negative 2 times negative 2. And the answer here, of course, is also... It's going to be positive or negative? It's going to be negative, because I've got an odd number of negatives. And 2 times 2 times 2 is 8. So the result is the same. Why do I care?
Because if we would have an even number of negatives,
Because if we would have an even, just like my next two examples, yeah? So if we have an odd number of negatives, it doesn't actually change anything. But if we have an even number of negatives, that's going to make the result different. If I've got negative 5 squared, no brackets, the base here is what? It's 5. It's not negative 5. That's the whole argument I've been trying to make for the last 10 minutes. This is the same thing as negative 1 times 5 squared. No brackets means I do the squaring first and then I multiply the negative 1. So then the exponent is going to be 2. The expanded form is going to be negative 1 times 5 times 5. That, of course, is going to be 5 times 5 is times negative 1, negative 25. But if I include the minus sign inside the set of brackets, what I have is this. Negative 1 times 5 in brackets squared. BEDMAS says I do the bracket multiplication first. Then I tack on that exponent. So now, William, what's the base? Now it's negative 5. And now we're going to square that. So then I'm going to have negative 5 times negative 5. Negative times a negative is a positive. 5 times 5 is 25. So when you have an even number of negatives, this is we're going to jump down here. Remember, blank number of negatives multiplied gives a positive answer. Even number of negatives gives it a positive answer. An odd number of negatives multiplied is a negative value. So there's a significant difference, and your calculators will handle these differently. Let's show you. If I write negative 2 to the 8, the result will be negative 256. If you're not really deliberate about how you handle these things, yeah? No, because I have an odd number of negatives here. This one is 3 negatives, this one's 2 negatives. This one is a negative times a negative is positive, times another negative is negative. What I'm trying to show you here is the difference between having an odd exponent and an even exponent, as well as the difference in notation. Does that make sense? Okay. So if you punch in your calculator this way, negative 2 to the power of 8 is negative 256, and then if you wanted to throw brackets in, you actually have to put the brackets in. Negative 2, close the bracket to the power of 8. This one will handle it properly, positive 256. This calculator, I believe, does it the exact same way. Negative 2, power 8, boom. Bracket, negative 2, close the bracket. Power 8, boom. Does it properly. I think one of these calculators actually doesn't. 2 negative, power of 8. See? This one doesn't. The Sharp calculator assumed I wanted brackets there. And I did not. So if you're sitting there with a Sharp calculator, I know that, William, you are. Quinn, I know yours isn't Sharp, but I'm willing to bet because it's a one-line display. Actually, punch that in. Just push negative 2 on your guys' one-line display calculators, and then go power of 8. I want to know what it says there.
It says negative 250.
Yours says negative 256, so your calculator does it properly. Your calculator says positive 256. Your calculator does not do this properly. Okay. Spend $12 and get a new calculator, please. You too, Quinn. You gotta have $12 somewhere. Mug someone at a gas station. I don't know. Get a new calculator. Do what you gotta do. Okay, so what difference do we notice? No brackets versus brackets. When the negative sign is outside the bracket, or there is no bracket, the negative does not repeat. When the negative sign is inside the bracket, it's part of the base and it gets repeated. A chart just like this will likely show up on an assessment for you at some point this chapter. You need to remember what the difference here is. Fractions are similar. Let's take a look at fractions. If I have a half cubed, what does that mean?
0.5.
No, we are not going to decimals. How dare you? Get those decimals out of your mouth. What does it mean to cube something? What does it mean to cube something?
A number times the power.
No. It is not a number times the power. Mr. Keeley, what's it mean to cube something? Haha. Funny. And then find the volume.
Times the number times number.
Times the number by itself this many times. Fractions are numbers too, guys. 1 over 2 times 1 over 2 times 1 over 2. And you did this test for me yesterday. How do you multiply fractions?
So it's just gonna be
No, answer my question first, Dea. How do you multiply fractions?
multiply the numerators together and the
Yeah, you just multiply across the top, you multiply across the bottom. There is no need I mean, we have common denominators, but we don't need common denominators when we multiply. So this is going to be 1 times 1 times 1 in the numerator, 2 times 2 times 2 in the denominator. Oh, look, what's happening here? This is the same thing as having 1 cubed over 2 cubed. The top gets repeatedly multiplied, and the bottom gets repeatedly multiplied. This is an exponent law that you looked at last year. Because you guys looked at exponent laws in grade 8. Or you were supposed to, if your math teacher followed the curriculum. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. We did it up at the top of the page. If I have 2/3 to the power of 4, what does that mean? Well, that's just 2/3 times 2/3 times 2/3 times 2/3. I can write it as repeated multiplication, and now we just march across the top. This is the same thing as 2 times 2 times 2 times 2 over one big fraction. 3 times 3 times 3 times 3, and we can do it without a calculator because these numbers aren't very big. 2 times 2 is? Times 2 is? Times 2 is? 16. The 3's might be a little tricky, but we can break them up nicely. What's 3 times 3? 9. So the 3 and 3 will give you 9. How about this 3 times 3? And then 9 times 9 is? 81. 9 times 9 is easier than 27 times 3. That's what we would have gotten. 3 times 3 is 9 times 3 is 27. If I'd asked you what 3 times 27 was, some of you probably would be able to reach to 81. But some of you would have been like, I don't know. I've never done 27 times anything before. And that's entirely reasonable. Because as soon as you have to pull out 27, well, you may as well pull out a calculator at that point. But there's shortcut ways to deal with this. 2/3 to the power of 4 is 1681. 16 over 81. What about this guy? Negative 1/3 to the power of 3. The negative is included inside the brackets. So what's the base here? Negative 1 over 3. So it's going to become negative 1 over 3 times negative 1 over 3 times negative 1 over 3. One of the ways I encouraged you to deal with this was to, when you've got the minus sign out front, bring it up to the numerator. It does not, hear me clearly, does not go on both the numerator and the denominator. It just goes onto one, and my recommendation is always to put it up top. Because it's not convention. Because you don't do it. The same reason that English is important, but math is importanter. Makes sense, but we don't say it. Because when you're speaking English and you talk about things being importanter, yes, you know what I mean, but it sounds like I got hit in the head. We don't say it that way. We just don't. Even though you understand. It's the same thing if I was to talk about Clifford, the big red dog. That sounds right. But if I talk about Clifford, the red big dog, it's the same thing. But it sounds wrong. Right? There are rules in English that we follow. There's rules in math we follow. Don't drop it down to the denominator. Because when you guys then find common denominators for like addition and stuff, you screw up. Don't do it. Okay. The other way to say it, though, is I've got an odd number of negatives, so my answer has to be negative. 1 times 1 times 1 is? I made it negative already. And then the 1 times 1 times 1 is 1. 3 times 3 times 3 is? 27. Okay? It's not hard, but there are details you must follow. And some of us don't like details and following details. You're just like, F the details, I just want to go. And that's how you're going to screw this stuff up. Math is a very detail-y kind of thing. Okay. Crank out this page for me. I would like to do lesson 2 as well, but we'll see. I want power, base, exponent, expanded form, and standard form for this whole page. On your mark and set, giver. And do I want to let you use a calculator for it?
Yeah. For the fractions. At least for the fractions.
Yeah, you can use a calculator for this. You will be allowed to use a calculator for this.
So bit of
Yes.
for the x times x, then the result would be another letter, right?
Sorry, what?
X times x times x.
Yeah, so what would be the base there?
The base x.
The base is x, yeah.
Is 5,
The exponent is 5, yeah.
and the result
No, it's not. It's not 5. Read it carefully.
Oh, 4.
It's 4. Yeah.
And the results can't be x. Right?
There is no standard form. That's why I blocked it out. Standard form will be the same as power form. Because you can't evaluate it because you don't have a value for x.
But wouldn't it just be
Yes,
y?
we will deal with negative. I'll show you how to deal with negative exponents. Yes. Exponents are allowed to be negative. It is not hard to deal with, but there are some, again, William, there are details.
You have to make it into a fraction.
You do. Or if it is a fraction, you make it into a whole thing. We'll deal with fractions, don't worry about it. Or fractions and negative exponents. Well. Crank them up. Yeah. In expanded form, yes. Yeah. Plus or minus 1 over negative 1 multiplied by 1. Yes. There are details. Finicky little details. That x versus multiplication x. I tried to make it. I could make it even clearer, I suppose. I could hold. Okay. Okay, where am I here? Pause you for a second for this. So negative 1 times negative 5 times negative 5 is going to be negative 25. This guy here, what's being repeatedly multiplied? The negative only shows up on the first one. The negative is not part of the repeated multiplication. Because if it was part of the repeated multiplication, it would show up on every 3, and it doesn't. So what's getting repeatedly multiplied? 3. How many times? 5. I heard someone say. So this is going to be 3 to the 5. How do I deal with that minus sign that's out front there? How does it show up over here? Anybody? Probably you look like a guy with answers. I want you checking yours with me as we go. Asavia. It's the same thing. It's the same as having negative 1 times 3 times 3 times 3 times 3 times 3. Writing it like this and writing it like this are the same. Except. Like, put outside the bracket. So you could write it, so you're saying write it like this? You could. Or you could just write it like we did before. With no brackets at all. These are the same. And then this guy would be negative 243. Okay, cool. Now it's inside the brackets. So what's the base here? Negative 9, exponents of 3. Negative 9 times negative 9 times negative 9. This result is going to be negative 729. Good. Negative 729. What's the base here? It's negative 3. Because the minus sign shows up on each one. What's the exponent? So then how am I going to write this as a power?
Negative 3, no, bracket, negative 3, bracket 5.
Good. That minus sign here must show up inside the brackets. Okay. Gentlemen over here, you're following along, yes? Okay. Okay. Negative's not part of it, so this is just going to be 9 to the power of 3, negative 1 times 9 times 9 times 9, which of course is going to be negative 729. 10 to 1,000 means I have to multiply 10 how many times? 3. The same number of zeros in the number. That's the beauty of having powers of 10. So it's going to be 10 times 10 times 10, which is 10 cubed. Cool. Base 1, exponent 7. 1 times 1 times 1 times 1 times 1 times 1 times 1 is 1. 1/3 to the 5. The base is 1/3. The exponent is 5. 1/3 times 1/3 times 1/3 times 1/3 times 1/3 is going to be 1 over what? 243. Oh boy, here we go. Negative 3 over 7 is the base. Exponent's 3, so it's going to be negative 3 over 7 times negative 3 over 7 times negative 3 over 7, which is going to be negative 27 over 343. Y and 6 and y times y times y times y times y times y. We good? Someone asked me to slow down. I will stop. Okay. What's being repeated and multiplied in this last one?
3/2.
3 over 2. Not negative 3 over 2, just 3 over 2. So it's going to be 3 over 2. It's multiplied 4 times. For the power form, we're going to have 3 over 2 to the power of 4. The fraction needs to be in brackets with the exponent outside. And because that minus sign is not included as part of the base, it also goes outside there, which is going to give us negative 81 over 16. And then the last thing here is, what do you do with the power of 0?
I don't know.
It is not 0. What does it mean to repeatedly multiply something 0 times?
It's 1.
I'll do an easier example, but explain it to me. Why?
I don't know.
Okay, here's why. 2 squared is? 2 times 2, which is? 4. Straightforward, yes? Okay. 2 to the 1 is? 2. Let's go one more here. 2 cubed is 2 times 2 times 2, which is 8. Okay, how do I march down the chart? What do I do to get from 8 to 4? How can I get? I can divide it, right? I can take this, I can divide 8 by 2. Gives me 4. It knocks out one of these 2's I'm multiplying by, so then 2 times 2 is 2 squared. Yeah? Same thing. Divide 4 by 2. Knocks out one of these 2's. This has a single 2, so then 2 to the 1 is 2. What happens if I divide by 2 again? 2 divided by 2 is? 1. Look what's happening to the exponent here as I march down. Was 3, dividing by 2 turns it into a 2, dividing by 2 again, knocks it down again to a 1. If I divide by 2 again, that exponent's going to become a, follow the pattern, 3, 2, 1, 0. And I just arbitrarily picked the number 2 here. It doesn't matter what this is. So anything to the power of 0 is 1. For this reason, which I will explain again when we look at it in this exponent law. Anything to the power of 0 is 1. So the exponent is 0, the base is 1, 2, 3, 4, 5. There is no expanded form, it's just 1. Doesn't make sense to repeatedly multiply something once. Okay, cool. If you finish the chart, you're done. And you all should finish the chart because I just did it for all of us together. So anything you didn't get done, presumably you wrote down. Bell goes in 6 minutes. There is no homework today. 6 minutes. 6 minutes. Tomorrow we will review the exponent laws that you were definitely supposed to look at in grade 8. Yes, Grandma. You betcha. You may back up, but you may not leave your desk. Return my calculators, please. Take your devices back.
Five.
Tower 5. You know, why there, why there, why there. 3. Why not 3?
Ya, itu lebih ya terapkan semana
Now you can see what happened. Oh, sorry. Okay. So when you want some time left, let's pull this back out. Have I done these with you guys yet? I thought I did these once, right at the beginning of the year.
ya.
Do another one. No, I don't think that was really hard.
Pero qué vídeos o cuál? Muy raro. Yo y por las mierda. Muy por las
That's super dark. Okay, here's a really dark one for you guys. You know what? No, never mind. That was a really dark one. So what happened here? Ooh, okay, here we go. So, Clara has an extraordinary ability, Sam, to be able to listen to the radio, carry on a conversation, or watch TV, any one of those three individual things, while reading a book. One night, Clara was watching TV while reading the book, and suddenly the power went out. Her husband decided to go to bed. However, Clara decided to keep on reading, even though the room was completely dark. What was she doing?
She was reading in the book.
But it's totally dark. How do you read in the dark?
She remembered everything, so she was reading.
And it's not reading.
She
Blind. Which means she's reading braille. Beautiful. Well, it's already dark for the blind people. Gotcha. Okay. Woo. Sid, Shady, and Sandslug were in a plane flying off the coast of South America at 300 meters. Sid and Sam were in the situation as a result of a bet. Sam claimed if he dropped a 5 kilogram steel ball from the plane, 6 seconds after Sid dropped a 5 kilogram sack of feathers, the steel ball would hit the ground first. Which of the two will actually hit the ground first?
Wait, how much did this book weigh?
They each weigh 5 kilograms. No.
Still, because the feathers have more aerodynamic, so they stop because of the air.
No. No.
The Tivo goes first.
Yes.
Oh.
Sid, Shady, and Sandslug were in a plane flying off the coast of South America at 300 meters altitude. Sid and Sam were in the situation as a result of a bet, yada yada yada, dropped a 5 kilogram steel ball from the plane. 6 seconds after Sid dropped the 5 kilogram sack of feathers, the steel ball would hit the ground first. Which of the two will actually hit the ground first? They're going to hit the water first, because they're off the coast. Neither of them will hit the ground first. They'll hit the water first. Yeah. Stupid question. Then the steel would hit the ground first because the sack of feathers probably going to float or sink slower than the steel ball. Okay. There have been many amendments to the U.S. Constitution during the previous 100 years. One of the most controversial items regards the transfer of power. Should one of the heads of state die while in office? If the Vice President of the United States and the Speaker of the House of Representatives die while in office, who becomes president?
The president.
The president, because the president didn't die.
Because the president didn't die, he stays president. If the president does die, it's the vice president. If the vice president dies, then it's the Speaker of the House. But if the president's still alive, he stays president. They all die, and they just keep going down. That's the whole premise of the show, Designated Survivor. Like, Have you seen the show Designated Survivor? Okay, so the premise of that show is exactly this scenario. They're all Congress, the president, vice president, they're all on a thing at the White House. When all of them gather together, there is one member of Congress that is not allowed to be there. Because should something happen to that group, that member of Congress, not allowed to be present, becomes the sole surviving member of the government. That person would then form presidency. And that's exactly what happens in the show. The first episode of the show, this guy is designated if something happens, you are the designated survivor. He's off site, and and Congress blows up. The terrorist attack that blows up Congress with the president, vice president, and the entire House of Representatives, except that one dude. It's an interesting show. Exactly what happened. Next question. Same but different. 6-7. Maybe. Underneath. Yes.
That's cute, yeah.
Have a good birthday, Osavia. How's it going, Pavney? I'm good, my ding. How are you?
How is you?
Super duper. How do I? Good morning. How are you? Good. Oh, what were you trying to? You trying to screencast or?
Well, I was connected my TV screen wirelessly,
Oh, okay.
and I thought I had chosen mine, but my TV wouldn't turn on for the bit.
Can we go to the library because our email said that it doesn't exist?
It says it does not exist. Yes, go figure that out.
Oh, by the way, I have to go at 9:35 for my field trip.
Right now. Have a great day. We'll see
Right
you later.
now.
You said 9:35?
Yeah.
It is 9:35. See you there, Zach.
Features mine, that looks really good.
It is very good. You just need one?
Yeah.
Just for you?
Well, I was gonna lend one out to a student, but my battery died, so I left it.
Send me your student.
Alright.
Send the student over here. I can give him one.
Yeah. I'll let
No,
it-
no, no. No, send me the gift. You know what I do if I'm gonna lend a calculator to a kid, they have to give me their phone.
Okay.
So if this kid needs a calculator, send him to Dawidoff. He can put the phone in the thing, and he can take one of my calculators.
I'll send her.
Or her, whoever it is. Okay. Yeah. Mm-hmm.
I'm gonna hide.
Mm-hmm. You do that.
Yeah. Welcome to pain.
Yeah, why do the Chiefs suck?
We're cursed. We can never have a good defense and a good offense at the same time. It's either one or the other.
You can't claim cursed and win 2 of the last 3 Super Bowls. You don't get to decline cursed.
I could be worse. It's back in like 20, like the.
Are you getting your
2010s,
test
we were
back?
all
No.
Garbage.
You just wrote them yesterday.
So I'm not
No.
worried about it. Like in 2021, we're in a similar situation, and we still ended up on the Super Bowls. I'm not like, I'm not worried. Not worried.
You know what the problem is?
What?
Taylor. Taylor's the problem.
Ironically, Travis Kelce had probably like one of his better games. Yeah. That game, so. They got get rid of Chris Jones. He could have totally got. All they had to do is touch down the line when he fell. He would have made the team down. They would have won. But there's no effort. The defense, they need to. Yeah, Chris Jones needs to be fired.